Basically, as you sort of enter into the building, you get into this it's like a wooden envelope where the logs also become the steps. You have the galleries below, restaurant in the middle, sort of sandwich between the galleries at the top and the bottom, opening up to the roof of the existing garage, and then from here you can sort of continue your way up until the top, where you have this big panoramic window that sort of looks over the mountains and welcomes people into Park City when they're sort of arriving from the main road. So this is actually a competition. After skiing next week, we'll be presenting it to a jury on Thursday. So it's like again this sort of idea of trying to sort of tap into the industrial heritage of the site and try to see if it can be sort of used for a new sort of cultural program. A similar example of abandoned infrastructure is a project we're currently doing in Copenhagen, where this is Shakespeare's Hamlet's castle in Copenhagen. It just became UNESCO World Heritage. It's almost impossible to do anything in Europe because everything turns UNESCO. It used to be the home of the Danish Maritime Museum. Now that it's UNESCO Heritage, they had to kick it out, and they proposed to put it inside this abandoned dry dock where they used to build ships. But the museum program was twice the size of the dry dock, so we would almost drown the dock in the museum. We thought, like, what if we could actually keep it open? It's like 150-meter long, 25-meter industrial cathedral, like a big void sunken into the ground. We started reading the reports on the dock, and the dock is in such a bad state that once emptied of water, the pressure from the surrounding soil would cause the walls to cave in. So we sort of moved we would have to like reinforce the dock from either the inside or the outside. So we thought, if we're going to make a new dock wall anyway to take the pressure, why don't we leave space enough so we can actually sandwich the museum between the old and the new dock walls, effectively turning the museum inside out. Like it's a giant void sunken into the ground. Also, there was an inherent dilemma in the project. It's like UNESCO said that the building had to be completely invisible. Obviously, the director of the museum and the sponsors wanted some kind of architectural masterpiece that would attract people to come and visit. And by turning it into a void, we could actually combine the need for invisibility with the desire for maximum exposure. So all we had to do was design a series of bridges that, you know, this one sloping down brings people into the museum. They are thick, so they have functions connecting shortcuts for the exhibition or auditoria or the restaurant. And also, even though we're completely underground and underwater, we actually have tons of daylight that's like brought into the museum through these bridges. When we designed the competition, we thought it was probably going to be hard to win because there was one main condition in the brief, and that was that you had to build inside the dock. And we, in theory, put everything around. But the jury liked the idea, and we won the competition. But then the Danish Architects Association, which is my union in Denmark, they sued the client for having chosen a project that broke the conditions of the brief, which seriously made me reconsider my membership of the Danish Architects Association. But happily, the client had gotten so into the idea by now that they say, okay, we cancel the competition and we hire Vic as our architect. So now we actually sort of broke ground, and it's just like, paradoxically, it's the tallest building we've built in Denmark. But it's from 0 and 40 meters down. But it's like really this strange process where the main structural challenge is actually to make sure that the building doesn't lift up and sail away. Because like it not only looks like a ship, it actually works like a ship sunken into the waterline. Sort of the last example of social infrastructure is literally dealing with current infrastructure. So of course you can reinterpret the industrial infrastructure of the past and turn it into cultural buildings, or like the High Line in New York, or the piers or the Hudson River Park. But in this case we got invited to look at a big infrastructure project outside Stockholm. They call it the Stockholm Gate. Essentially they're doing a huge highway interchange that becomes the main arrival to Stockholm from the northwest. And they wanted to create some kind of a landmark that makes people aware that they're coming to Stockholm. But if you look here, we took like Arc de Triomphe in Paris. As you can see, the site is so huge that what they really need is an urban master plan. Like the two highways are going to separate the three neighborhoods from each other and the three parts. So somehow to create the connections between them would make sense. So if what they wanted was a landmark and what they needed was a master plan and urban connectivity, what they had a lot of was excavation soil. They've been digging like miles and miles of tunnels. So our sort of main idea is because the highways, the noise is pushing the different neighborhoods away. So we propose to simply use all of the excavation soil to create a man-made valley that actually allows the city to grow all the way and sort of almost like touch the rim of this like a gentle bowl or crater, if you like. This valley becomes a public park that connects all of the different neighborhoods, and each of the neighborhoods can actually sort of extend all the way to the edge of the crater. Like a sort of gentle valley. You get this sort of circular perimeter, almost like not a waterfront, but like a green front. The city sort of looking out over this like new valley. But we still didn't have a landmark, and it didn't really make any sense to put like some kind of giant function in the middle. And when you're driving over the highway, you don't see the life of the park around you. You don't see the valley. So looking around, we found this satellite developed by NASA in the 60s. It's a giant sort of inflatable, very strong, completely reflective fabric. And we thought, almost like an old road mirror, we could make like, it's a giant globe, it's 100 meters diameter, and it's hovering above the highway, so it actually sort of turns the park and the life of the park into the monument or the landmark. Essentially, it reflects the views of the surroundings, of course. Like, we actually did the competition right before Christmas, and we had one of these Christmas tree balls lying around. So it seemed like a slightly crazy idea, but we would anchor it down in 3 points, and we could actually harvest the pistons of the anchor points, could actually produce a little bit of energy. The solar exposed hemisphere could produce photovoltaics enough to power a part of the surrounding neighborhood, and 10% of the energy we would tax to drive a pump that would keep pressure and hot air inside the balloon to keep it floating. Even if there's a catastrophe and the stuff deflates, we can make sure that it doesn't land on the cars. So we put it in, and in a way, sort of, it became like this completely immaterial landmark that it doesn't contain any mass. All it does is it reflects the life around the landmark itself. And like strangely, we won the competition, and are now sort of charged with the idea of trying to make this floating mirror ball a reality. So. This has led us to like our biggest project to date, which is we got commissioned by all of the 10 municipalities of metropolitan Copenhagen to look at